Today's experiment is crystallization. The purpose of this experiment is to introduce the technique of crystallization, which is the most common procedure used to purify crude solids in organic lab. And with this experiment, you would learn various new techniques. First of all, crystallization. And during crystallization, you would use vacuum filtration and in order to filter out your crystallized product. Melting point in order to analyze whether your crystallized product is pure or not. You would learn how to find a best crystallization solvent based on the solubility, and then mixed melting point in order to basically analyze whether the compound is pure or not, right, or the two compounds are same or not. And then the critical thinking application. You can predict basically the crystallization solvent based upon the solubility and structure. This experiment is divided into 4 parts, part A, B, C, and D. So in part A, basically you would crystallize the impure sulfanilamide using the crystallization solvent, which is 95% ethanol. In part B, impure sample of an organic compound fluorine is given, but the crystallization solvent will not be given. So you need to first of all figure out what is the crystallization solvent, and then you would crystallize impure fluorine using the procedure of part A, and then find out the melting point and everything. And in part C, basically you would determine the identity of an unknown compound using the mixed melting point technique. And in part D of this experiment, basically, which is critical thinking applications, the goal is to predict the appropriate crystallization solvent. So basically 3 of the solvents will be given for one structure. So you need to determine which is the best crystallization solvent based upon of its solubility and structure. And later you would basically check your predictions using the Merck index. So in the Merck index, the solubility is given, and so that's how you will learn how to see the Merck index and how to apply the critical thinking in order to determine the best crystallization solvent. Materials and chemicals used for this experiment: impure sulfanilamide, impure fluorine, 95% ethanol, toluene, methanol, deionized water, orthotoluic acid, succinimide, benzoic acid, benzoin, acetyl salicylic acid, Erlenmeyer flasks, melting point capillary tubes, boiling chips, melting point apparatus, and then connected to it is data recorder, hot plate, vacuum pump for vacuum filtration, Merck index for part D, and then you would need other things from your lab drawer, for example, measuring cylinder, watch glass, pipette, glass rod, spatula, and maybe some more. Now the chemical waste. So all the organic waste of this experiment will go to the non-halogenated organic waste container. So let's start part A of this experiment, which is the crystallization of the impure sulfanilamide. And for that, you are going to weigh, first of all, 0.75 grams of this compound, impure compound, into the Erlenmeyer flask. And then you would add minimum amount of the boiling 95% ethanol. Right, so you are going to add the minimum amount. If you will add more amount of it, then you will not get the good recovery of the crystallized product, and as well as the crystals will not be pure. So it should be minimum amount. So in order to find, just to have an idea, I have used this graph, which is mentioned on page 681 in your pre-lab calculations. It's mentioned there. So I'm talking about actually this graph right there. So this is a graph between temperature and solubility, right? So at 78 degrees centigrade, which is the boiling point of the ethanol, you will calculate how much of the boiling ethanol is needed for the sulfanilamide, right? So when I calculated, I end up having like about 4 milliliter of it. So I have an idea it should have a minimum 4 milliliters of the boiling ethanol in order to dissolve completely sulfanilamide. So this is the mass of sulfanilamide. And I have already tiered the Erlenmeyer flask before adding the sulfanilamide into it. So as you can see here, this is the flask. It has about 15 milliliters of the 95% ethanol. So I have kept here. It's just warm right now, but I will let it boil. And after when it starts boiling, I'm gonna add the this boiling solvent into the sulfanilamide, which is already weighed, just to barely cover the crystals, as you can see. And then I'm gonna swirl it, try to dissolve it, and then in the intervals I'm gonna add like 0.5 milliliter at a time, again swirling, dissolving, swirling, dissolving, so that I can have like a minimum amount of the crystals in the boiling solvent. As you and you can see, basically I have added the boiling stone here, which will prevent the bumping and the superheating. So for that, it's must to add the boiling stone. Some main points that you must keep in mind for any crystallization. Basically, we should not heat the crude compound. In this case, it is sulfanilamide, before or adding the solvent or not adding enough solvent into it. It might happen that the compound will melt, right? And then it will be very difficult to crystallize it. And then when you will add the hot solvent, as I already mentioned, you are going to add the hot solvent in small proportions, so that add the hot solvent in a little bit and then swirl it and try to dissolve so that you will get the minimum amount. And another common mistake, it happens then when you will add too much solvent into the to the compound in order to dissolve. So it will be very quick to dissolve, but then the results will not be good. You will not get the enough recovery, right? And then the crystals will not be pure, and the shapes of the crystals you will not get the way we were expecting, and you will get a powder, right? The impure powder with low recovery. So that's the main important thing, that the boiling solvent should be as minimum as possible, so that's the main thing. And if the solvent is water, let's say, in this case, the solvent is 95% ethanol, so boiling point is 78. But then if the crystallization solvent, let's say, is water, right? So you need to dry the crystals for a good amount of time. Or sometimes we might have to leave the crystals overnight in order to remove all the water before checking the mass of the recrystallized product or the melting point. Now you can see the solvent is boiling, 95% ethanol, right? So this is boiling, so I just lower down the heat here, otherwise there will be just unnecessarily boiling of the solvent and we were losing the solvent unnecessarily, right? So now I will barely cover the crystals with the boiling solvent. And I will try to swirl it. So I've added actually about 1 milliliter of the boiling ethanol into it. And as you can see, I made a mark just for the reference. So here comes about 1 milliliter. So I measured it using the measuring cylinder, and that's how it came to about 1 milliliter, and that much actually I have added. So that I know that I have added so far 1 milliliter. And then I'm gonna add 0.5 milliliter at a time. It just stopped boiling, so I'll increase the heat so that again it will start boiling. And then after that I'm gonna add 0.5 milliliter at a time in order to dissolve it, so that I will get the minimum amount. So I have added so far 2 milliliters of the boiling ethanol to it, but it hasn't been dissolved completely. So I'm gonna continue my process to get the minimum solvent. So now I'm going to add the last 0.5 milliliter in order to have like all 4 milliliter as per the pre-lab calculations. And then I'm gonna swirl it and see whether it will be completely dissolved or not. See, now after enough swirling, it did not dissolve completely. So I'm going to add 0.5 milliliter more. Maybe some of the solvent has evaporated while swirling, so with that it will be total now 4.5 milliliter. So I've added about 4.5 milliliters. Some of it evaporated as well, so it will come down to actually about 4, but that's the minimum I tried. So that's the minimum amount, and you can see the sulfanilamide is now completely dissolved into that much amount, right? And the solvent is still boiling. You can see here in this flask as well. So the condition is the boiling solvent is very important, right? So, and now what I will do, I will remove the flask from the heat, and I'm gonna put it into at the bench top, and I'm gonna cover it with the small watch glass, and I'm gonna let it sit here so that it will gradually cool down to room temperature. As you can see, the crystallization is started now here. It's at room temperature, so beautiful crystals of sulfanilamide, they are forming. It hasn't been come at room temperature, still warm, but then you can see the sulfanilamide is beautifully crystallizing out. Now the flask is at room temperature. It took about 10 minutes to cool it down completely and come into room temperature, and I can see there is no more crystallization is taking place at room temperature. So I have made here the ice and water bath here, and I'm gonna place this flask into the ice water bath for about 15 to 20 minutes in order to increase the crystallization. I will let it sit for about 15 to 20 minutes, and after that we're gonna proceed further. So now crystallization is over. It's been now 20 minutes. The flask is sitting in the ice bath. I just removed some water out of it because it was too much watery because ice was melted. So now we are going to filter the crystals through the vacuum filtration. So this is the setup for the vacuum filtration. This is the vacuum pump. That's the filtration flask. That's the Buchner funnel, and I have already added here the Wortmann filter paper. And this is the trap. So trap is needed so that the filtrate should not go into the vacuum pump and it should not damage the vacuum pump. So it's very important to have the trap. And you can see the connections right there. It's basically, it should be connected this way. Now I'm going to turn on the vacuum pump. I'm going to show you how it has basically the suction. So as you can see, my hand is kind of sucking down, right? As you can see, it has a good suction. So because of that, the vacuum filtration is basically a fast process. I have kept another beaker, and it is the ice water bath. I have 95% ethanol. It is chilled 95% ethanol. Using this, I am going to wet my filter paper. Filter paper is wet. Now I am going to slowly remove the crystals slightly. And I'm going to transfer these crystals onto the Buchner funnel with the help of the spatula. Now you can see still the crystals are here, right? So what I will do, I would take basically 2 milliliters of the chilled ethanol into the measuring cylinder. I will add that chilled ethanol into this Erlenmeyer flask. I will slowly swirl it and basically will try to transfer all the crystals into it. Now this way what will happen, that I'm gonna basically transfer the crystals. At the same time I'll give the washing to this crystallized product. So whatever the impurities are associated with this right now, it will be dissolved and come to the filtrate. So it will basically serve both the purpose. You might have to add another 2 milliliters. So in total you might have to have 4 milliliters. So depending upon that, how much does it take to completely transfer the crystals. So here I'm going to add about 2 milliliters of the chilled ethanol. And I'm going to slowly swirl it, and I'm going to gently transfer it. Still you can see I still have something in here. So I'll try to take 1 milliliter first and then another 1 milliliter. So you can see now I have transferred completely the crystals from this flask onto the bleacher funnel. It took 4 milliliters. If you will add more, you are basically dissolving your sulfanilamide into the ethanol, and then it will pass to the filter. So you will lose your crystallized sulfanilamide into the filter, then the recovery will be more. So the thing is, you should have minimum amount that is required to transfer the crystals from the Erlenmeyer flask to the bleacher funnel, and then the ethanol should be chilled. If it is at room temperature, the solubility will be more. So in chilled solvent, the solubility of the compound is less. So it's very important, it should be minimum amount of ethanol to transfer, and it should be chilled. Now you can see this is the shape of the crystals. They look pretty nice, needle shape. So looks like the sulfanilamide, what we will get, it should be pure. But we will check the melting point and see that how much is it pure. Let it set this here for 15 to 20 minutes so that it will be completely, all the ethanol is sucked and it will be completely dry. I'm going to take the mass of the watch glass because I'm going to transfer my crystals of sulfanilamide onto it. So the watch glass has to be pre-weighed. So this is the mass. So it's already 15 minutes since the crystals are drying, and it's time to turn off the vacuum pump. And I'm going to slowly remove the vacuum. Now I will remove the Buchner funnel, and I'm going to completely transfer basically all the crystals on the pre-weighed watch glass. So as you can see, I have transferred maximum of the crystals from the filter paper to the pre-weighed watch glass, and some of the crystals are still stick to the filter paper. But if I will scratch this filter paper more, I will start scratching the filter paper, and that will add to the weight of the sulfanilamide. So you can see that how are the crystals. They are fine needle shaped shiny crystals, and in order to prevent the having the crystals around and to have all the crystals on the watch glass, it's good to have a butter paper below the watch glass. So whatever the crystals falls around it, you can basically recover them by adding into the watch glass. So that's way you will not lose your sulfanilamide much or any compound which you are crystallizing. So now we will take the mass of this sulfanilamide, and you can just subtract the mass of the watch glass in order to get the actual mass of the sulfanilamide, crystallized one. So this is the mass of the crystallized sulfanilamide. You need to subtract the mass of the watch glass in order to get only the mass of the crystallized sulfanilamide. So now it's time to record the melting point, right? So we already crystallized our sulfanilamide, but how we can say that it is pure? So we need to analyze it by taking the melting point. And so we basically gonna take the melting point of impure sulfanilamide as well as the crystallized sulfanilamide. So let's see how you can do it. So now I am going to take out little bit impure sulfanilamide. Onto a watch glass. You do not need any contamination to your pure sample, so make sure everything is nice and clean. Make sure your glass, watch glass and everything is very clean. Then I'll take the pure crystals. So now the time is to fill the capillary tube, the melting point capillary tube. And they look like this. They are closed at one end, right? And they are open at the another end. So basically we are going to fill the sample through the open end. Now when you fill the sample, make sure your sample should be even. As you can see, the crystals, they are not even. So we are going to make in a powder form. And so is the impure sample. So we would use either the capillary, test tube, right? The back side of the test tube, or you can use the spatula as well. But make sure everything should be clean. So I'm gonna, clean the bottom of the test tube, and let's see the impure one. So I'm gonna crush it to a powder to make the sample even. As I mentioned, you can use the spatula as well, but I find, this one is basically much effective and easier to use. And pick the capillary tube. Now I'm going to tap it in a tapping tube, and make sure the height of the sample in the capillary tube after tapping through the tapping tube, which I'm going to show you in a little bit. So the height of the sample should be between 1 millimeter to 2 millimeter, not more than that. If you will pack too much, you will not get the correct melting point. So this is my capillary tube. It has basically the impure sulfanilamide, right? So this is my tapping tube. So I'm going to slide here, and you can see it's bounced. So I'm going to do it like 3-4 times. So after packing through the tapping tube, the height of the sample is about 2 millimeter, and basically I have checked the length using the ruler. So you can use the ruler to make sure the length. If again, as I mentioned, if you will take too much of the sample, you will never get the correct melting point. Okay, and make sure your capillary tube is labeled. So I stands for impure, because I'm gonna put the pure one, which we already crystallized, right? So that I'm gonna pack the capillary tube same way as I did for the impure, and then I'm gonna put it into the melting point machine. Now you can see I have packed my both the capillaries, right? Impure sample and pure sample. It's good to label all the time. Okay, now this is the melting point machine which we are going to use. Okay, and so let's focus on this area. So basically this is the right now it is in the cooling mode, right? So it's not heated at all. So I know what is the melting point of the sulfanilamide. It is 164.5 to 166.5 as per the Mark index. So I need to heat my machine, right, in order to melt the sample. So as you can see, this is the rapid heat section, and it would basically heat the machine more than 10 degrees centigrade per minute. So I'm gonna turn it on, turn to this side, right? Now this is the data recorder. This is the LabQuest. This is kind of an interface, and that's the data recorders. As you can see, the temperature is rising here, right, very fast. Now, I already mentioned the melting point of sulfanilamide is 164.5 to 166.5 degrees centigrade, right? Now, when I would see my temperature here comes around, 135 or 140, or I would say around 140, I would basically decrease the temperature, decrease the rate of rising the temperature, and set it up around 170 so that I will not miss my sulfanilamide melting point, and the heating should not be very fast so that it will be difficult for me to record the melting point, right? Now, in the meantime, you can place your capillary tubes. So you are going to place the capillary tubes. Here you can see there is a aluminum heating block, right? And there are slots are made. So I'm going to put my sample pure, let's say here, and impure is here. So there are 3 slots are given. So you can put it right there. Right, and this is basically the eyepiece, or you can say the magnifying glass. From here you can look your samples. So I'm not sure if you can see clearly. The capillary tubes are visible here, right, with the samples in them. So basically, since the temperature is not raised at all, I mean it didn't reach to its melting point, so you would see just only the solid samples as you just placed them. Right, these are the solid samples, clearly are visible. And once it started melting, you would see the liquids in there. So you are going to basically record the range of the melting point. And the range of the melting point means once you see first drop of the liquid in the capillary tube, very first drop, that's your starting range, right? And once you see all the sample in the liquid is melted, that's your end part, or end part of the range. So there is the melting point is always in a range, right? So starting range and the ending range. And it should be very, for the pure sample, it should be short, right? It should be very sharp range, like between 1.5 to 2 degrees centigrade, not more than that. An impure sample, basically it has a broader range. An impure sample also melts at a lower temperature than the pure sample. So you need to keep all these things in mind when you will record the melting point. So now, as you can see, the temperature is close to 140. So I am going to turn my dial to 170 so that it will gradually, come to the, so that it will gradually started heating the, machine, not at such a high rate. It is still not melted because the melting point hasn't been reached, right? And so as you can see now, this temperature is not rising at that high rate. The melting point hasn't been reached yet, but the temperature is increasing, and you can see the capillary tubes as well. They are the same as you have seen before. The sample, it didn't start at all. So the sample is about to start melting. It just started melting now. You can say 156.8. Since it is an impure sample, so range is going to be broad. and it is still melting. And it's almost there. So it's all melted now. So you can see 160.4 degrees centigrade. And that's the sample. You can see the the left hand side melting point tube, the impure sample. It's in the melted form. So the sample has not started melting yet. As you can see, the sample is still solid into the right hand side melting point tube. So it just started melting. Still melting. And it's melted completely. So these are the melted samples. The left one is the impure sulfonilamide and the right one is the pure sulfonilamide. So now we are done with the sample, right? Melting point recording. So now I'm going to turn off the fan of the machine in order to cool it down. Right? Let's say I'm going to record another melting point of fluorine or any other sample. So the machine has to be cooled down. I don't know what is the melting point for another sample. Maybe it is less than 166 degrees centigrade, right? So I have to bring the temperature down. So this way, this is a rapid cooling mode, and that's how you can decrease the temperature of the machine fast. And one thing also, see, we have used basically the interface here, LabQuest 2, right, in order to record the data. But you can use your cell phone as well with this machine, and you can connect via Bluetooth, and you can record the data in your cell phone. That's the another interface you can use. So now I'm done with these samples, right? So you can dispose them off in the glass waste in the lab.